Need to dynamically discover and use AI prompts in your FastMCP tools without hardcoding them. You'll see how to programmatically list available prompts and retrieve specific ones with arguments, all through the FastMCP context object. This pattern keeps your tools flexible and maintainable by letting you access prompts at runtime, just like any other server resource.
Hash list available prompts. Prompts await CTX. List prompts. Hash get a specific prompt with arguments. Result equals await CTX. Get prompt. Analyze data. Dataset. Users. Messages equals result messages.
This demonstrates the context injection pattern, where framework capabilities are provided to functions through dependency injection rather than global state or manual instantiation. The pattern centralizes access to cross-cutting concerns like logging, progress reporting, and resource management, while keeping your business logic clean and framework-agnostic. What makes this distinctive is how it decouples tool implementation from infrastructure dependencies, allowing functions to remain pure while still accessing runtime services. The pattern works by treating the context object as an implicit parameter that the framework injects at call time. Your functions declare what they need through type hints, and the framework satisfies those dependencies automatically, without requiring you to wire them manually. This creates a clean separation where tools focus on their core logic, while the framework handles dependency resolution, lifecycle management, and transport concerns transparently. This approach solves the problem of how do I access framework services without polluting my functions or creating tight coupling. It's particularly valuable in RPC systems, long-running operations, and modular architectures where you need to share capabilities across many components. The trade-off is that your functions must be async to work with the injected context, but this is a small price for eliminating dependency boilerplate and making your tools more reusable. Let's break it down line by line.
Hash list available prompts. Prompts await CTX. List prompts.
This lists all available AA callable prompts from the current context. The CTX object provides prompt management, and this call retrieves their names for inspection or selection.
Hash get a specific prompt with arguments. Result equals await CTX. Get prompt. Analyze data. Dataset. Users.
This fetches a specific prompt template by name while injecting runtime arguments. The CTX getPrompt method retrieves the analyze data template and merges it with the provided dataset parameter, enabling dynamic prompt generation with context-specific values.
Messages equals result messages.
This extracts the message list from the prompt result. The messages property contains the formatted instructions and data that will be sent to the AI model, including any variable substitutions from the provided arguments. Prompt engineering pattern. The getPrompt and listPrompts methods bridge static templates with dynamic execution, transforming reusable message structures into context-aware conversations. Arguments passed to prompts are automatically serialized to JSON strings, but the server must know the expected schema, document your prompt contracts. This pattern enables prompt reuse across different clients while maintaining type safety through serialization.
The prompt that forgets its arguments remembers every conversation